Morning, morning. Hello, hello. All right, sorry. Having a bit of screen sharing difficulties. I don't know what's going on with my computer here, but can't seem to get the second monitor to work, so oh boy, that doesn't help. Anyways, I'm trying to fix my setup here. I'm not sure what's going on, but things are not being my friend. So I'll just give me a couple minutes. I'll see if I can get her going while you guys are logging in here. See if this works again. Probably not. Hey, there we go. I don't know why that was being so annoying. Alright, so let's go back to that. Beauty. Okay, we're alive. Oh, that's real tough, man. You sitting there without your name on it. Oh, what is my question of the day? Yeah, I was lazy this morning. I just said, "Morning, everybody. What's my question? I gotta change my question." Let's go with. Let's go with that. Hit me up in the chat. What's your first sound? Ben, you're weird. Oh, Crest. There's a big Crest crew here. I have not started reading After yet, Cam. I don't know what it is, but if it's... Oh, yeah, it's free. You said it was free. Okay, I should go... Fine, I'll read the first chapter tonight. That'll be my goal. Every day I'll read a new chapter. I'm going to grab my toothpaste because I don't even know which one I have. So give me 1 second. Man, does anyone use anything other than Crest? Dawn dish soap. Logan, you're a real man. No, never mind. Tomato sauce wins. That's disgusting. I figured out what I use. It's the worst. I use this stuff, Colgate Max Fresh. Normally, I use like one kind of toothpaste and I get sick of it because you're on your own. I'm on my own. So it takes me forever. I shouldn't say it takes me forever to go through a tube of toothpaste, but longer than like your family would. I guess you guys in the dorm, you feel me if you guys aren't sharing toothpaste. Like it takes forever to go through like a whole massive tube. And anyways, I went to like the grocery store, and I go to the Real Canadian Superstore, so they have like these like deals of the day, and their deal of or I think it was deal of the week was toothpaste, and I had forgotten to grab it. It was on my list. I'm just like, oh, I need to go get toothpaste, and they sold me at the counter. They're like, oh, we have these 3 tubes, and it was like a pretty good deal. And these were the tubes, these Max Fresh things, and it came with 3 of them. And like, I think there's an expiry date on toothpaste, and this stuff is disgusting. I would never recommend it. It's that kind where it's like, you guys probably can't see it that well, but it's like that blue gel with the little like whitening strips in it. I don't know. I'm more of the white cream colored paste. This stuff is like toxic. It makes me gag. This is the first tube of 3, and you can basically see it's like almost full still. Brutal. I'll be back. Sorry, I gotta put my toothpaste away. Attendance today is brought to you by Natural Factors Vitamin C. Take one a day. Chewables that come in multiples of flavors, and peach, passion fruit, and mango is my favorite. It keeps me awake, lively, and healthy. There's 180 chewable wafers for only $10.99. Great deal. Lots of ad placements here. Good Dove Vitamin C. Yeah, the Walker Boys, shout out. You guys told me vitamin C, so I've been on that train. Okay. I know, but I can't afford Jameson, so get off my back. All right, I'm rocking attendance here. Where is that darn thing? There it is. All right, attendance. Let's see how we do. I think I saw Paula in the chat there. Yeah, everyone give me a here just once, just so I know you're here. I'm pretty sure I saw Paula, though. Paula, where'd you go? Yeah, there you are. Perfect. Logan is here. Cam told me to read a book. Max, I saw it. Did I see Dafe? Dafe, where are you? Yeah, awesome. Welcome, welcome. Kyle, let's see. Wowza. We had a lot of chat messages today. Oh, there's Kyle. He said, what's popping early on? Cool. Paul, let's see. Don't think I see just Paul. So Paul, if you could give me a message, let me know you're here. That'd be sweet. Yeah, awesome. Thanks, Paul. Same thing with Crystal. I don't know that I've seen you yet. Yalds, I don't think I've seen Yalda yet. Izzy, yeah, he's here. Awesome. Thanks, Izzy. Yeah, thanks, Crystal. Awesome. Got you. David is here. Awesome. Wendy. Sorry, attendance takes so long, guys. Yep, Wendy's here. Awesome. I think I saw both of the Bassett and Batten. Yep, perfect. Welcome. Ty, as usual, is not here yet. That's rude. I shouldn't say that. He's not here just yet. He will be, hopefully. Lenice, I saw. Zoe, I saw. Daniel and Liam, I saw. Benny, I saw. Jerry is MDZZ. Ty's on TikTok again. Man, he's probably trying to get more followers than me. And Huey Dooby Doo. There he is. Okay, so just missing Ty and Yalda. Ty and Yalda. If they show up, that would be swell. I'll just mark them present when they get here. Cool. Cool. Yeah, hopefully, you guys had a chance. Somebody said, I saw in the chat early on, did we have homework last night? Typical. Let's see if you did. You were supposed to be doing, I believe, numbers 4, 6, and 18. We cut it down for you. So from numbers 4, 6, and 18, I've got like too many notifications on here. Let's switch back to just our regular programming. Oh, this isn't going to work at all today for our green screen, I don't think. Because my shirt... Oh, it works okay. Because my shirt is too close of a color to that, but it's not terrible. It's not great. It's not great, that's for sure. All right, so where did we get to? I was asking you guys if you have done your homework. So 4, 6, 18. Hey, Ty. Welcome, man. Let me just mark you here. 18 EF. Absolutely. Yeah, we'll take those up. Thanks, Zoe. Yep. 18F. Yeah, let's do 18. Absolutely. 17. I don't think we had to do 17. Someone. Now I feel like y'all are messing with me here. Wait. Yeah, 18. Yeah. Okay, good. I'm gonna have to remind myself. Sorry, give me 1/2 second as I open your textbook because I forget exactly what those questions look like. I can just open it, but I like to maybe show you guys as well. So let's see. Oh wait, wrong textbook there. Where are you? There you are. Let's see here. I forget what page it was on. Not 500, that's for sure. Which chapter am I in here? Chapter 6, too far. Perfect. Chapter 4. What am I at right now? I'm at 4.7. Okay, a little bit further back. What is this? 4.4. Yowza. Okay, I will get there. 4.2, I believe. Yeah, all right. So y'all wanted 18, E and F. Cool. Let me just open up the things I need here. Yeah, someone says 18. A lot of you guys said 18. Let's rock. So yeah, so I see 18. Man, it seems like we just want a lot of 18, right? Let's do that then. Let me just take this here. Just do like a little x squared 5 minus r. Yeah. Okay, so basically you're multiplying this, right? So you're taking 5 minus r. It's a whole thing, and you're multiplying it by 2. And so here, I'll just go like split screen somehow. Hopefully this works. So you guys will be able to see this. So basically for 18a, we'll get your x squared, and then the 5 minus r, you kind of, because there's no brackets, and it's interesting, like if the minus r wasn't in, my eyes go see-through sometimes, that looks a little demonic. Because that minus r, like what would it be if it wasn't part of that exponent, right? It has to be all together, like a 5 minus r thing there. And so you'd take that 5 minus r and you'd multiply it to that 2. So you go x to 2 times 5 minus r, and that would be x to 2 times 5 is 10 minus 2r. So 10 minus 2r should be your answer there. Sorry. Oh, sorry. Sorry. I had to sneeze. That was aggressive. Here, because we are dividing for 18b, looks like people want 18b. Thanks, Kyle. Somebody in my grade 9 class said I look homeless today. Oh, a white kid wants me to dab. But you can't see because my friggin' sweater is the same color. And it's messing with the system. I gotta get a different shirt on. I get see-through sometimes in this shirt. Anyways, let's do this division here. So we would have b to the 2m plus 3m. And really this is divided by b to the m minus n. Oh, I didn't even have to dab. I just constantly dab due to instinct, eh? And so remember, we subtract our exponents. So this would be b to the 2m plus 3m minus, we're minusing the one on the bottom, m minus n. And then we get b to the 2m minus m would be just m, and then 3. Oh, LSU goof. It'll be much easier, right? What am I doing with myself here? This 2m plus 3m, that's just 5m. I don't know why I was making that into, I thought there was another n there. So that would just be 5m, right? It's kind of stupid. My bad. So we just have your 5m minus m minus n now. So 5m minus m would be 4m. And then minus negative n would be plus n. So 4m plus n. There might have been an issue if the textbook got something different than me. I wonder if the textbook meant one of these to be an n, you know what I mean? So if that's where the question is coming from, you guys let me know if this isn't a good enough explanation. If that's what the textbook had, I can go look. It's just my the PDF, I don't want to lose a spot when I just have that single PDF. It's kind of annoying to scroll down. So does that make sense for that question? I bet you if there's a different answer in the textbook, it's because they messed up and they didn't do 2m plus 3m. Dang, this being see-through here makes my neck look extra long. Never mind. Now it's not see-through and it just looks really long in general. I just have a long neck. Alrighty then, let's move on. Are we good with this one? Thumbs up if you're cool with B. I had another request. Looks like I had a lot of F's. You got something different? Okay. Should be this. Should be this. I can go look and see what you had. Cam, I'm gonna just drag your thing up here. That way no one else can see. Cam 4. Yeah, Cam, you have 4m minus n, but you forgot to do the minus minus, and 2m plus 3m is 5m minus an m. Would be 4m, but you just forgot your little minus minus. That's the only thing that our differences were there. So I don't know why I needed to keep that. I thought we were on C. Oh, okay. She thought we were on C. Awkward. Sorry, Cam. Where was I? I'm lost. Unit 4, 4.2. Awesome. Let's head back down to here. Cool. So, and we're on F now, right? If the textbook says negative n, it is wrong because you would be doing divided by negative n, so it's technically you're subtracting a negative n to be positive n. So the textbook is unfortunately wrong. Sorry about that. And then our F. Yeah, you guys want a refund on the textbook? Ooh, this one is nasty, so I'm happy you guys asked about this one. I'm going to deal with everything inside the brackets first here. There's a couple interesting things you need to kind of think about though. So let's do that. So in this big square bracket, we'll just deal with that first. And then I'll leave the 1 over x to the m on the outside. This 6 minus m here, technically, I don't think I'm gonna be able to write on it. No, I won't. It just moves it as I type my pen on it or touch my pen to it. You need to take that 6 minus m and you need to put it through to the exponent of 4, as well as 3 is like another thing in there, right? This is 3 times x to the 4. Even though we think of this as 3x4 as like one term, it's a 3 times x to the 4. So maybe I'll just write out one more step here, because technically that's 3 to the 1 x to the 4, right? Technically there's a 1 above that 4, that 3, my bad. And that would be its exponent. So when we look at this 6 minus m, you need to look at putting that 6 minus m through to both of those exponents. It's just like if I had, let me just grab a tissue, one sec. Sorry, that 6 minus m needs to go through to each thing. I was gonna give you it's just like if I had like 3 times x cubed, right? So what would this look like? Well, this would look like 3 times x times, that'd be 3 times x 3 times, right? 3x, 3x, 3x. So there's 1, 2, 3 3s, so 3 cubed, and 1, 2, 3 x's, x cubed. And that's why you can just think of this little exponent having to go through every single term, right? It's because it's being repeated. And so if that exponent is more complicated, like in our case, it's like 6 minus m, right? That 6 minus m has to go into the 3 as well as the 4 as well. So we're multiplying, because remember it's our power of a power rule. But basically, sorry, Bat, I just came up with this random example. I didn't get cubed from anything. Sorry, I'm just saying that this was my it's like this. Maybe that was more confusing for me to do that for you, but I'm trying to give you an alternate example. Dumb things down to explain it. That way when we do something more complicated like this, it makes a little more sense. So that's gonna be 3, and then it'll be 1 times 6 minus m, so just 6 minus m. And then times x, and it'll be 4 times 6 minus m. And then that would all still be inside that big square bracket, and then we still have 1 over x to the m afterwards. So you guys hit me up in chat if you have a question about that first step I did. All I did was I made sure that 6 minus m went to both exponents there. This pixelation is killing me. I don't know if it's killing you guys today. I feel like this sweater, here, I'm gonna take this sweater off. Hopefully that works out better. Nope, it does not. Sorry. I figured the gray t-shirt would do it. Maybe we'll just go back to regular. Okay. Ben wants just me to be a floating head. Okay, all right, so let's skedaddle then. Let's finish this question because we're not done just yet. Now what we need to do is we need to think about common bases, right? bases that are the same. I have a base of 3 and a base of x here. So those things cannot be put together, right? We can't add those exponents. So right now we have this term multiplied by this term multiplied by this term. Now, 1 over x clearly is a different base than x, but we can make it look like they're the same base. So we're going to work a little bit backwards here. That might be a little bit confusing to you, but you remember how if I have like x to the negative m, that would be the same thing as we flip. We do the reciprocal of x, right? So we make it 1 over x, and it becomes positive m. So looking over here, 1 over x to the positive m, I can just rewrite that as x to the negative m. And the reason I want to do that is because now I would have two terms with the same base, this x and x here. I should go full screen. Sorry, I don't need to share that on half screen with you guys anymore. But I have two terms with the same base, or I will have two terms with the same base. Yeah, exactly, Kyle, we can rewrite it. So this is really 3 times, to the exponent 6 minus m. And then x, let's do our 4 times 6 is 24. And then 4 times minus m is minus 4m. So that's all in the exponent. Sorry if that's a little bit nasty. And then this thing just becomes, instead of 1 over x to the m, it'll be x to the negative m. And I've just wrote them all beside each other. They're all multiplied, right? They're all multiplied by each other. Even though they're different types of brackets, like square brackets, it's really, now that we've got that a little bit less nasty, it's just because there was 2 layers of brackets. That's why they changed it up. But really this is this times another thing. So we can write them all like this. And now what we can do, hopefully you guys are following this, is put those last 2 terms together. So remember, we need to add our exponents, right? Add our exponents. So we'd leave this as equals 3 to the 6 minus m, and then it'll be x to the, well, we're gonna do this thing minus this thing. Oh, sorry, no, we're adding them. Ugh, what's wrong with me? We're adding them, right? So it's because we're multiplying, it's subtract when you divide. So we're multiplying 2 bases, same base here. We can't do this one, it has a base of 3, but these, since they're both x, we can add their exponents. So 24 minus 4m plus negative m, so it's really negative 4m minus another m, right? So we'll get 24 minus 5m. And that is our final simplified expression. Looks like Ty gave us an answer earlier. He said 3 to the 6, 3 to the 6 minus m, that's what we got, times x to the 24 minus 5m. Awesome. So we got the same thing as Ty, or Ty gave us the answer from the textbook that we were looking for. I'm not sure, one of the two, but thank you, Ty. No, that's aggressive. Can y'all give me a thumbs up that you're cool with that example, and we can move on to today's lesson? Or if there's any other questions you have for me, hit me up. That would be fantastic. I'm just gonna check. I feel like I got a thumbs up from the Walkers. Bassett says move on. Okay. Get a Coolio, cool like ranch. Doritos, Cool Ranch. So, hey, who am I missing still from attendance? I think I'm still, did I ever mark Ty here? Let's find out. I wonder if we still get to do dress down Fridays. It's kind of dress down every day now, isn't it? Yeah, just y'all away today from what I see. All right, so hopefully that helped you guys. Let's skedaddle. I believe I've sent you today's note. If that's true or not, it's to be determined. Buttons. You guys are still in uniform. Oh, that'd be pretty funny. I'd love you just using them as like PJs now or something like that. It's like, I sleep in my uniform now. I just miss school so much. Okay, that didn't have to sound so creepy, I guess. Anyways, let's freaking motor. We are... You pay $5 to wear your uniform on Fridays for a month, yeah. Where are we at? We're going to be on 4.3. You guys got 4.3? Let me know if you're missing 4.3. I don't need to know who's got it because I'm just going to assume everyone has it, but let me know if you are missing 4.3. All right, I think that would mean everyone's got it. I see no messages about you not having it. So today is going to be, do you remember we did that day in class where I had you guys go around in those little groups and basically you went to different stations and you learned like a rule about radicals. Remember, they were all about square roots. Today is kind of ish like that, I guess, because we're going to look at the easy version of that. Like this 9 to the half, you guys should remember that was like the same thing as the square root of 9. And then like 9 to the exponent 1/3 was the cubed root of 9. I don't know if you remember that one station we had where you learned that. Today's a little bit like that. Obviously, we're going to get more complicated than that and add variables and things like that into it. But that's kind of the basis for today. So I won't spend too much of your time or waste too much of your time. Anyways, I'm happy you guys are here. I'm happy it's super exciting hearing from you guys and all that. Yesterday I did my first Teams class with international business. And so I actually got to hear their voices, all the people that wanted to talk to me. I miss hearing some of you guys' voices. So I feel like we should do some sort of like Teams meeting discussion or something like that soon. That way I hear all you guys, although there's more in this class than there was in my international business class. But seems like a lot of your teachers are switching to Zoom now anyways, or at least they will be next week, even the ones that are not yet. It seems like a lot of the teachers are liking Zoom better. And we're going to learn how to use that Friday morning when you guys got late start day, or the people that don't know how to use it are... I think it's pretty self-explanatory, but we'll see how she goes. Right, so if you guys type 9 to the exponent of half in your calculator, that would be the square root of 9. Or it would tell you 3, right? If you just did 9 to the exponent 1/2, should I do this? Why not? Let's insult your intelligence for a second here. You guys know I know you love when I do that. So let's just throw it in our calculators here. Whoa, that was weird. Whoa, where the heck is OneNote? Did I close everything? Sorry, OneNote. Oh, it's probably because I have it on full screen. So if we type in 9 to the exponent 1/2 or 0.5. Oh, that's 0.55. Everything's gone wrong. Hey, it says 3. That's crazy. We already all knew that, so love it. Full screen. 9 to the half is 3 because it's really the square root of 9. And the square root is really like, it's the second root, right? Which is kind of weird to think about. Over here, if you type this one in, right, it'd be the square root of 16, which is 4. And if you type this one over here in, it'd be the square root of 4, which is 2. So what the heck do you notice? Basically, the denominator becomes the root. So it's the square root of all of them. I'll give you a minute to write that down, and then we'll boogie and do the next one. So I'm pausing, you write, and I'll be right back with you in a second here. I'll just take a drink of water while I wait for you to copy that down. I'll ask you if you're done when we do longer copies. This one, I think probably half of you already started this note because the homework, if you weren't paying attention in that part or whatever it would be. I never took anyone's game recommendations yesterday. I saw that there was that Borderlands 3 was on sale, and it was like the first time I played a video game in years, and I remember playing like the old Borderlands, like 1. Actually, I don't think I played 2, but anyways, I played 1, and I really liked it back in the day, but this one is like significantly more trashy. So anyways, I don't know that I enjoyed video games as much as I used to, so I may just go for a run tonight, see how she goes. Or I have to read a chapter of that book as well. Okay, let's do this. So hopefully you guys have got that. Call of Duty Warzone, it's free. Okay, on PlayStation, Ty? It's free on PlayStation because that's what I have. 8 to the 3rd is the cubed root of 8. Cam says definitely read the book. Super Meat Boy. Oh no, I've seen like YouTube videos of that. It's like nasty, man. It's just like a little meat dude going through saws and stuff. Yeah, I would hate that. I'm a pacifist. I don't believe in violence. Anyways, if the 1 over 2 was the square root, the 1 over 3 is the cubed root. And so you're looking for 3 numbers that go together to multiply to 8. So we know that's 2. Lenice, I did read my Bible. Thank you for asking. That is lovely. It's also a little bit like you're attacking me and making sure, but I appreciate that. Can we do the 4th root of 16? So we're looking for now 4 numbers that multiply together to get 16, right? So if we tried 4, it'd be 4 times 4, 16 times, okay, that's too big, right? So maybe 2 again. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Yeah, thanks, Batten. So it'd be 2, right? Okay, so all of that stuff is pretty easy. Let's just pretend you're like walking in the wild and there's like a skill testing question to win some sort of lottery ticket or something like that. So basically, actually, you know how, like, I don't know if you guys have ever seen things with a skill testing question. Normally something with a skill testing question is when they had a contest and it's like chance. So it's like, you know, call into the radio, even like things where you have to call in the radio for caller number 9 or something like that. Basically, it's really interesting because in Ontario, you're not allowed to gamble unless like you're like an official like Ontario lottery thing. And so if there's some sort of radio station that wants to hold some sort of contest where it's fluke, where it is lottery, their little back way around that is they do these little skill testing questions. Then it's not like, oh, it wasn't all chance. They had to know something too. They had to like answer a question. So it's just kind of funny. That's where that whole concept came from. It's like anytime you see a skill testing question, it's like, okay, you won something by chance, so you have to answer the skill testing question to go along with that. It's kind of interesting. So what happens if you see a number like 8 to the 3 over 2? Here's your skill testing question, but you just dropped your calculator in poison ivy, so you can't use it, and you're so sad. So how would you do that? And this is the part where we didn't talk about last time. I'm pretty sure, we only did ones like this, right? Where you have 8 to the 1/3, 16 to the 1/4. It's always a 1 in the numerator of that, right? It's a little rational or a little fraction in the exponent. So we only saw ones like that. What would happen if you have a number other than 1 in the numerator there? And we're going to look at that right now. So basically, what you could do, you could look at this, right, as x to the a over b, kind of like separating things. Maybe I'll draw it for you in another step. If we have something like x to the a over b, that's kind of the same thing as like x to the a, and then outside there's a little exponent like 1 over b, Do you see that being a b, right? Because we multiply when these things are in brackets like this, right? So a times 1 over b is just a over b. And that's why you get this little x to the a. And when you have an exponent of 1 over b, right, that's like having the bth root of that x to the a bit up there. And so we can think of this whole deal here, this 8 to the exponent 3 over 2. You can think of that as, and you can do it either way. Like technically I can think of this as 8 to the exponent 3 and then 1 over 2. So that would be the square root, right, of 8 cubed. That's one way of thinking about it. Or you could also think about it instead, right, or 8 to the 1 over 2 cubed, like outside like that. That's another way of thinking about things. Now, the square root of 8 isn't nice, right? So if I was to do this, it'd be the same answer, right? 1/2 times 3 or 3 times 1/2. But the square root of 8, and then you cube it on the outside. There's no square root of 8 that's a nice number, right? So it's not really going to be a helpful option for us. I'm just saying you could do either way. So the 8 cubed, 8 times 8 is 64. Ooh, 64 times 8. I told you guys you had to do this without a calculator, so I have to figure this out. If we had 64 times 2, for instance, that'll be 128. So we need 4 128s. 2 128s is 200 and, okay, whoa. 2 128s. 2 28s is 56, so 256. So we need 256, that's 512. Yes, Batten, you win. You beat me to it. 512. Yeah, oh my gosh, that was difficult. My brain is not good. So the square root of 8 cubed was 512. Oh my goodness. So we're supposed to do the square root of 512? Is that even going to be possible? What times what is 512? 12 is 144. Oh my gosh, I don't think I'm going to be able to do this, guys. My brain is not going to work for me. 64 maybe? 64 times 64? Let's pretend I don't have a calculator right now in my hands because I dropped it in Poison Ivy. Okay, technically this one's too difficult, but it's not. We can do this. Dang it, I was way too high with the 64. It'll be like 16 times 16. Nope, it'll be 17 times 17. Nope. Okay, I'm not even close here. It'll be like something over 20. 21 times 21. Dang it. Frig, let's just do the square root of 512. I'm getting the Poison Ivy, I'm risking it. Oh, it's not even a nice number. That was a bad example. That was a bad example. It's not a nice number. It's a decimal. That's why we couldn't do it. It's 22.6. Anyways, that was me just coming up with the idea, like, how would you kind of think things through? So that's not going to be possible for us there. 8 to the 3 over 2. That little jerk. Just write dumb, because your teacher's dumb. Okay, I'm going to give you a second to not write. No, we don't need to write this crap out because that technically didn't work, so it was wasting your time. Let me just do example B, and then I'll let you guys write that out. Sorry about that. That's too bad. So what we'll do instead... Oh, man. I'm such a goon. So we'll do this part B because I know this one's going to work out. So I'm going to write this as, and you could choose, negative 27... And I could have that as my little 1 over 3 in there first. And then outside I could square it. And I'm going to do that one because if I squared 27, again, I'm going to have to use my calculator. But I know that the cubed root of 27 is 3, right? 3 times 3 times 3 is 27. 3 times 3 is 9. And then times another 3 would be 27. And you can actually have cubed roots of negatives. I know you can't square root a positive number, right? But you can square root a negative number, but you can cubed root a negative number. And the reason for that is that if I have -3 now, it'll be -3 times -3 is +9, times another -3 would be -27. So the cubed root of -27 is -3, and then I just square it, and I get +9. So that one worked out. So I'm going to let you guys copy that down. I'll just leave that right there. I don't know if anyone wanted that top bit. I doubt it. But anyways, I'll leave that right there for you. And I'll let you guys take a minute. Give me a thumbs up when you're ready to move on, because I kind of butchered that first example. I apologize. It turned out it wasn't a nice number, and we wasted a lot of brain power or something that wasn't really worth our time. Lenice, what did I learn in the Bible? Ooh, that's a good question. I don't remember what the Devo was on last night, or the little, I do that Our Daily Bread. Should grab it for you later. Kyle, I'll go over B again, okay. Cam's giving me the classic Cam emoji where you finger gun or something like that. I don't understand. E.T. maybe, I'm not sure. So that -27, we're doing, technically this 2/3 can be rewritten as, right, 1/3, sorry, rude, 1/3 times 2. That's the same thing as 2/3, right, 2/3. And then that 1/3 will be the cubed root of -27. That's what I've written here. And then the cubed root of -27, you could just type that in your calculator technically, but let's just go to understanding here. We're looking for a number, multiply itself 3 times to get 27, and actually specifically -27. So 3 times 3 times 3 is 27. If we do -3 times -3 times -3, that'll be -27. So the answer to the cubed root of -27 is -3, and then we square it afterwards. I think I could probably do this C as well. And the reason I know I can do C is that if you have this nasty decimal like this, this is really 16 to the exponent -3/4, right? I think we could all do that. And then I know that 16, and I could write this one as 16 to the 1/4, and then to the exponent -3, right? Because -3 times 1/4 is -3/4. The 4th root of 16, right? If I give myself some more room here, that's the 4th root of 16, and we'll still have that -3 on the outside. What times what times what times what is going to be 16? It'll be 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So this would be 2 to the exponent -3. And remember, basically when I have a negative exponent, you flip it. So that's 1/2 to the exponent now +3, and 1/2 to the exponent +3 is just going to be, well, you could put that exponent through to every term. So it'll basically just be 1/2 times 1/2 times 1/2, which is the same thing as 1 cubed over 2 cubed, right? Just basically, you've got all 3 numbers on the top. It'd be 1, 1, 1. So it'd be 1 over 2 times 2 times 2, which would be 1/8. You can just cube both terms. I'll just write that step out for you guys. It'd be 1 cubed over 2 cubed, so that's 1/8. I'll just zoom out like that so you can see B and C. Give me either Cam's finger guns or a thumbs up or if we're ready with this one, or hit me up with a question in the comments if you need something there. Oh man. You can do a loading emoji. How come the answer isn't negative if it is to the exponent -3? Well, again, it's a little penguin. Yeah, that's like my new favorite. Okay. Well, the reason that it's not negative is because it's an exponent that is negative, not the number itself. And so you can type that in your calculator, but really the negative exponent, remember, that just causes a reciprocal. It doesn't cause the number itself inside to be negative. It just causes you to flip it upside down. That's all. What else did I? Oh, Zoe, on your useless website things, I also found this, which doesn't do anything. It's just a pickle, a donkey, and a knife. Just that's the website, so it just loads there. I can only do websites, so they just load up there. So anyone that you have to click, it doesn't work. So a lot of those you had to click, it didn't work. But anyways, there's a pickle, a donkey, and a knife. Yeah, super random. And then obviously my bouncing cats one is the legendary. Jerry, so we're not doing the square root, we're doing the cubed root, right? So you can do the cubed root of a negative because if we think about it, right, the cubed root of negative 27, you're looking for 3 numbers that multiply to get you negative 27. So if it was 2 numbers to multiply to negative 4, and they have to be the same, it's not possible, right? Because you could do 2 times 2, which would be positive 4, or negative 2 times negative 2, which is still positive 4, so it doesn't work. So this is not possible. But down here, if I do negative 3 times negative 3 times negative 3, you'd have, you know, this here would make positive 9, right? And then timesing by the last negative 3 would allow us to do 9 times negative 3 is negative 27. So it allows us to get a negative answer for a square root, cubed root. Cubed roots can be negative. Anything that's odd actually could be negative. Even if it's the 5th root, you could do the 5th root of a negative number. Does that make sense? And then our last little rule is actually one I've already kind of explained. It's this one right here, this 1 over 2 cubed. Technically 1 over 2 cubed, right, is just 1 over 2 times 1 over 2 times 1 over 2. And that's why I said 1, 1, 1 is 1 cubed over 2, 2, 2 is 2 cubed. Sorry, 2 cubed like that. So that's kind of what we were doing a second ago. You don't have to write that down. Sorry, we're getting a little messy with this note. But this part here, this 2 over 3 cubed, right, that's the same thing as 2 over 3 times 2 over 3, times 2 over 3, which would be the same thing as 2 cubed over 3 cubed. So that's why I just say there's this last rule where you can put the the exponent in here and here. So that would be 2 cubed over 3 cubed. And you can see that here in our general form, we have a to the n over b to the n. Just be like that. So I'll just do one hard example. Can you guys give me a newt if you're good to go? Or if you need a question or you need a second to copy that down, hit me up in the chat. Give me a newt. If you are good. Cam's good. Kyle gave me a penguin. Jerry gave me a cat in a box. Zoe's claiming the penguin emoji. Logan has a 5 number in a hand in a stop sign. Kyle's now using the bat. That's very nice of you, Kyle. I got Batman. I'm Batman. All right, home slices. Let's finish this sucker up. Let's just do like one tough example, and then I'll shut up. Dealio? If you've got this one, let's just do a slightly easier one first. The cubed root of 1 over 8. Well, remember what I said, where that exponent that goes on the outside, you can think of, right? You can think of this cubed root as the same thing as 1 over 8 to the exponent 1 over 3, right? That cubed root is the same thing as 1 over 3. And so this really could be, and I'm probably causing more work for myself than necessary, right? That 1 over 3 is going to go into your exponent on the 1 as well as the exponent on the 8. So it'd be 1 to the 1 over 3 and then 8 to the 1 over 3. And then all I would do is just say, oh, that's the cubed root of 1 over the cubed root of 8. Like that. And you know the cubed root of 1, it's like, what times what times what is 1? Well, it's 1, you friggin' weirdo. And then the cubed root of 8 is 2. And that makes sense, because even if you were just to step back for a second, undercomplicate things, name 3 things that multiply to 1 over 8, well, it would be, right, just in general, if I have 3 1/2, 1 over 2, 1 over 2, 1 over 2, that gives me 2 times 2 times 2 is 8, right? There you go, that's perfect, that's what we wanted, and 1 and 1 and 1. So the answer to this would be 1/2. Just did that in overly complicated sense. I'll give you a second to write that down, copy that, and then we'll do the last tough example, which is that way, in a minute here. Let me take away my newts. I think we need a little bit more pickle donkey knife in our lives. Giving you a second to get that down, and then I'm almost done because I know we're getting near the end of class here. We're already at 10 after. Je comprends. Good French there, Batten. All right, we've got our pickle donkey knife in the way a little bit there. I'll get rid of that in a second here. Let's do this last one, the cubed root of -8 over 64. Make a wish. I wish that all children in the world could one day see Niagara Falls for the first time. That's it. I could probably wish for something more noble than that. That people could drink lots of coffee and not be addicted and get headaches when you don't have it on the weekend. Yeah, Zoe, I thought about wishing for the virus, but I figured other people probably wish for the virus at 11/11, so it's probably fine. Ben is calling me racist for not allowing children to see Niagara Falls for the second time. Dude, once you've seen it once, you've seen it all. It's a falls. Water goes over it. It's not that cool. Come on. All right, let's friggin' move. Dang it, Zoe, every time you say that's what she said, I try and think back to what I said that would have caused it. That's what she said. I don't think I said any. Anyways, quit messing with me. Cubed root of -8, right? That's going to be -8 to the, and we could put this is all the same thing as 1 over 3, right? So -8 over 64, and basically you'd have the whole thing to the exponent. Ooh, that's supposed to be a 1/3. And then you'd have -8 to the 1/3 over, oh, once you've seen it, that's not that good, come on. Would she really say that? I don't think so. -8 to the 1/3, that's the cubed root of -8, right? Technically you could just go, oh, it's the cubed root of this over the cubed root of that, right? It's the same idea, but I'm just probably taking more time. The cubed root of -8 is -2. Oh, sorry, Zoe. Wait, you're offended that I said that's what she said wasn't that good? I don't think that's reason to be offended. David says, nah, she wouldn't say it. She wouldn't say it. -8. So it's -2 times -2 times -2, right? So that would be -2 is your cubed root. And then the cubed root of 64, I'm going to assume it's 4. Let's think about it. 4 times 4 is 16, times another 4. Yeah. Yeah, it's 4, right? 16 times 4? Yeah. Yeah. 32 and another, yeah, it's 4. So -2 over 4, and you can simplify that to -1 over 2. Hallelujah. Oh my gosh, look at that homework. Team, give me 1 sec. I'm going to shorten that homework. That seems excessive. Unless, like, are you guys, like, really bored at night? Do you want homework? I'm not sure. I don't want to, like... Okay, don't do 2. Number 3 is good. I like number 3. So we're not doing 2. 5 is good. 6. Yeah, I haven't made you do that many from those. Yeah, actually, you know what, guys? Really only 14. Maybe just pick a few from 14. Okay, pick ones that you think are going to be hard. So I think the only one I would reduce really is 2, because the other ones will take you like no time at all. Like you'll be able to finish that in the next 20, I would think. It's not that bad. If you're looking to cut some out though, maybe keep 14, and then maybe cut out some of the earlier ones, right? If you don't have enough. Dang it, Cameron, now I can't remember what I said again. When you say that's what she said, can you put me in quotations to what I said? The nerve. Anyways, I shouldn't be promoting the that's what she said jokes. We're just all bored, okay? I got so much copy. All right, I'm gonna end the stream. She is my best friend. Hit me up with them questions, but I'ma end the stream. Trend zone. Ask away on Teams. Anyways, guys, I'm going to take off. My internet's being a jerk, so God bless. Have a good day. Keep it real.